Now let us discuss about the nature of roots of a quadratic equation x square plus bx plus c is equal to 0 where a not equal to 0. Now, so what are called roots? According to the quadratic formula, the roots given by x equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay. So here the two values represents the roots of such quadratic equation. Now the nature depends upon this value. Observe this value. What is that value? B square minus 4ac. Suppose that it is greater than 0. Then roots are x equal to minus b plus or minus square root of b square minus 4ac by 2a. That means if you want to write the two roots, one according to plus and the second one according to minus b minus square root of b square minus 4ac by 2a. So here these two roots are according to the case b square minus 4ac is equal to 0, and we may observe that both are real and distinct, means two different real numbers. Now observe another case. In case if b square minus 4ac is equal to 0, that means then while writing two roots, x equal to minus b and this is 0, so by 2a, and second root here also value is 0, so minus b by 2a. Observe these two. Here also these two are real but equal. So two roots will exist under this case, but both are real and equal. Now observe the third case. In third case, when b square minus 4ac value is less than 0, then what is x? Here under this square root, we can observe a negative value. So that value, that is minus b plus or minus square root of b square minus 4ac by 2a. These are called imaginary roots. Imaginary roots, or according to set theory, these are called complex numbers, and these are distinct by this plus or minus. So here observe this, the nature of roots depends upon the value of b square minus 4ac. So here the nature every time depending upon the value of b square minus 4ac. That's why this b square minus 4ac is called discriminant. B square minus 4ac is called discriminant of this quadratic equation ax square plus bx plus c equal to 0. So now remember that when this value is greater than 0, roots are real and distinct. When this value is 0, roots are real and equal. Finally, when roots are imaginary or complex numbers according to b square minus 4ac less than 0. Now in these three cases, let us observe the graph of the quadratic equation. We know that the graph is always one of the parabola. Graph of a quadratic equation is one of the parabola. So in such a situation, the graph may be either like this or like this. That means here we can observe the intersection of the parabola with x-axis at 2 points. The intersection of parabola with x-axis at 2 points. When b square minus 4ac is equal to 0, then roots are real and equal. According to this nature, the graph may be either like this or like this. That means here the parabola will touches the x-axis at a single point. The parabola touches the x-axis at a single point because of roots are real and equal. According to this case, the parabola, it doesn't touches the x-axis either like this or like this or some other cases like this. Okay, so there is no attachment of parabola with x-axis. So this is about the